Good morning, welcome to new lecture. Today I will talk about dot product and cross product. There are two different methods we can multiply two vectors together. One of them it is dot product, another it is cross product. Let's first look at the dot product. If we have two vectors like vector A and vector B, and the angle between these two vectors, assume it is theta. A dot to B is equal to, we define in this way, vector A dot to the vector B is equal to magnitude of vector A times magnitude of vector B times cosine of angle between these two vectors. So A dot to B is equal to magnitude of vector A times magnitude of vector B times cosine theta. So we can write B dot to A will be equal to magnitude of the B times magnitude of the A times again cosine of angle between A and B. If theta is angle between A and B, the angle between B and A, for example, if one of them is clockwise, I assume it is positive, another one will be negative, minus theta. But because cosine theta is equal to cosine negative theta, we know that. So from here we can understand A dot to B should be equal to B dot to A. This is one important thing you should know. Another important thing you should know, A dot to B answer, because you see here magnitude A times magnitude B times cosine of angle between those two vectors, the answer will be a scalar quantity. So the answer is only magnitude, it is a scalar quantity. If I, for example, draw another picture, for example, vector A, this is vector B assume, and this is angle theta. So we defined A dot to B is equal to magnitude of A times magnitude of B times cosine of angle between A and B. So you see here, for example, I can write this A cosine theta times B, they are equal. A cosine theta, it means we will project vector A in the B direction. This will be A cosine theta. So the dot product, it means the projection of the vector A in the direction of the B times B. If we look at the cosine, if we have one circle, this is cosine direction, this is sine direction, theta is equal to the 0, cosine theta 0 will be 1, theta is equal to pi over 2, the cosine will be 0, and theta is equal to pi, the cosine will be negative 1, because this is cosine axis, this is sine axis, so theta, if this is angle theta, theta is equal to 0, cosine will be 1, theta is equal to pi over 2, means here the cosine will be 0, and theta is equal to the pi, means here the cosine will be negative 1. So if we have two vectors, they are parallel, means the cosine of angle between those, it becomes 0. In that case, dot product will be maximum. So for theta is equal to 0, we know cosine 0 will be equal to the 1. So A dot to the B, it becomes maximum. From here, for example, let's look at to the A vector dot to the A. A dot to the A will be the magnitude of vector A times the magnitude of vector A times the cosine of angle between A and A, because now we have only one vector and we multiply A to the A, the cosine of 0 will be 1. So A dot to A will be A squared. So vector A dot to the vector A, the answer will be A squared, and the answer will be scalar. For dot product, so now we know A dot B is equal to vector B dot A. If you remember this property, we will call it commutative property. We can prove A dot to vector B plus vector C will be equal to vector A dot vector B plus vector A dot vector C. We call this distributive property. So for dot product, those two properties, we can have it A dot to B is equal to the B dot to the A dot to the B plus C is equal to A dot B plus A dot C. Let's see if we represent two vectors in Cartesian vector form, how we can conduct dot product. Assume we have vector A in Cartesian vector form, AXI plus AYJ plus AZK. And we have vector B again in Cartesian vector form, which is BXI plus BYJ plus BZK. Now A vector dot to the B vector is equal to, it will be AX BX I dot I plus AX BY I dot J plus AX BZ I dot K plus AY BX J dot I plus AY BY J dot J plus AY BZ J dot K plus AZ BX K k dot I plus az by k dot j plus az bz k dot k. And you know I, j, k, they are unit vector in 3 directions. I is unit vector in the x direction, j unit vector in the y direction, and k is unit vector in the z direction. They are unit vector and they are perpendicular to each other, and the magnitude of each vector, it is unit, it is equal to 1. From here we can write I dot to I, vector I dot to the vector I will be magnitude of vector 1, which is 1, times the magnitude of vector I, which is 1, times cosine of angle of I to I, it is 1. So I dot I will be equal to the 1. How about I dot j? The magnitude of I is 1, the magnitude of j is 1. The cosine of angle between I and j is 90 degrees, it is 0. That will be equal to 0. Or j dot k will be 0. Or I dot k will be 0. From here, this term will be 0, 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 and this term will be 0. So only terms which they are not 0, it is this term plus this term plus this term. They are not 0. From here we can write vector A dot to vector B. If we represent vector A and vector B in Cartesian vector form, it will be AX BX plus AY BY plus AZ BZ. So, if we have two vectors now, if we have two vectors like vector A and B, and we represent these two vectors in Cartesian vector form, we know A vector dot to B vector, it is AX BX plus AY BY plus AZ BZ. On the other hand, A dot B is equal to magnitude of A times magnitude of B times cosine of angle between A and B. So from here I can find the angle between two vectors, vector A, vector B. If this angle is theta, cosine theta will be equal to A, vector A dot vector B divided by magnitude of A times magnitude of B. So I can write this AX BX plus AY BY plus AZ BZ divided by the magnitude of vector A times magnitude of vector B. So I solve one numerical problem. Assume we have two vectors in Cartesian vector form. One of them it is vector A, another vector B, and we want to find angle between these two vectors. Vector A in Cartesian vector form, it is 2i plus 2j minus 1k. Vector B it is 5i minus 3j plus 2k. Now we have two vectors. We know these two vectors in Cartesian vector form. We want to find angle between these two vectors. So I can write cosine theta is equal to A dot B divided by length of A times length of B, or magnitude of A times magnitude of the B. So A dot to be in Cartesian vector form, it will be AX BX 2 times 5 plus AY BY 2 times negative 3 plus AZ BZ plus negative 1 times 2 divided by the magnitude of vector A, it means the length of vector A, it will be square root of 2 squared plus 2 squared plus negative 1 squared times the length for vector B will be 5 squared plus negative 3 squared plus 2 squared. From here I can find cosine theta is equal to 2 divided by 3 square root of 38. If you take inverse cosine, you will find theta 84 degree. So the angle between vector A and vector B, it will be 84 degree. Now let's look at two other type of multiplying vector A to vector B. We call it cross product, to see what is the difference between dot product and cross product. That is simple concept too. Let's now focus on the cross product. So in order to compare even, I can divide this screen to two parts. One part dot product, I talked about that already, again I will write. Now this side I will write cross product so you can compare. Cross product okay. Dot product we define vector A dot vector B was magnitude of A times magnitude of B times cosine of angle between two vectors A and B. Cross product A cross B will be magnitude of A times magnitude of B times sine of angle between A and B times unit vector. Cross product answer, it is not a scalar quantity. The cross product answer will be a vector quantity. So this is unit vector. And A cross to the B, the answer will be one vector in the direction of the n unit vector, and that will be perpendicular to the vector A and vector B both. So the unit vector n will be perpendicular to the vector A, and unit vector n will be perpendicular to the vector B. So the answer for cross product, it is a vector quantity. The answer for dot product, it is a scalar quantity. The vector will be perpendicular to A and B. How we can find the direction of that? If the answer of A cross to B, A cross to B, it is a vector perpendicular to the AB plane. So in that case, that vector should be pop out from this whiteboard or pop into this whiteboard. How we will recognize the direction The direction we will find using right-hand rule. Right-hand rule says you will put your index finger in the direction of A, middle finger in the direction of B, thumb finger, it will show the direction of cross product. So here the cross product A cross to the B will be one vector which is perpendicular to the AB plane, so it will be popped into the whiteboard and it will be in this direction, and you will put index finger in the A direction, middle finger in the B direction, and will be perpendicular to this whiteboard. And let's see how about theta. Theta is equal to the 0. In that case, sine theta will be equal to the 0. Theta is equal to the pi over 2. Sine theta will be equal to 1. Theta is equal to the pi. Sine theta will be equal to 0. From here, we can understand cross product answer. It is a vector, and if these two vectors they are parallel, it means angle between two vectors is 0. The answer it will be 0, and it becomes maximum whenever these two vectors they are perpendicular to each other, because if vector A and B they are perpendicular to each other, this angle is 90 degree or pi over 2. In that case, you see sine theta will be equal to 1. So, if A and B they are perpendicular to each other, the cross product answer it becomes maximum. From here, you can understand another important property. Let's look at this definition one more time. We define A cross B is equal to magnitude A times magnitude B times sine theta between A and B. B cross to A will be magnitude of B times magnitude of the A times sine of negative theta. Because if from A to B the angle we measure, for example clockwise, is theta, B to A it will be counterclockwise, it will be negative theta, and sine negative theta is equal negative sine theta. From here, we know A cross to the B will be equal to negative B cross A. So A vector cross B vector is equal negative B cross A vector. And from right hand rule, you see that because A cross B will be pop into whiteboard, B cross to A will be pop out from whiteboard. So the direction will be different. So the direction will be different. Another property you can write A. So from here we see in the dot product A dot to B it was equal B dot to the A, but here we cannot write that. A cross to B is equal negative B cross to A, and vector A cross vector B plus C will be equal to A cross B plus A cross C. We can write that. And another thing, if you remember, A dot A, it was A squared. But here, A, vector A, cross to vector A, because angle between A and A is 0, the answer will be 0. Let's represent vectors again in Cartesian vector form and see how we can calculate cross product in Cartesian vector form. So if we have again two vectors A and B in Cartesian vector form, A is equal to AXI plus AYJ plus AZK, and vector B is equal to BXI plus BYJ plus BZK. In that case, A cross B will be equal to AX BX I cross I plus AX BY I cross J plus AX BZ I cross K. In similar way, we can write AY BX J cross I plus AY BY J cross J plus AY BZ J cross K plus AZ BX K cross I plus AZ BY K cross J plus AZ BZ K cross K. We know I, J, K, they are unit vectors. So X, Y, Z, I, J, K, and they are perpendicular to each other. I cross to I is equal to 0 because it will be magnitude of I, which is 1 times magnitude of I, 1 times the angle between I and I, it is 0, sine 0 is 0, it is 0. J cross J, it is 0. K cross K, it is 0. Because unit vector, we should put hat. But how about I cross J? I cross J, it will be, I'm doing for one, others you can find yourself. It will be the magnitude of I, it is 1, magnitude of J, it is 1. The angle between I and J, it is 90 degrees, it will be 1, times the unit vector, which is perpendicular to the IJ plane, it will be K. So I cross to the J will be K. In order to figure out fast, I, J, K. I cross to the J will give you K. J cross to the K will give you I. K cross to the I will give you J. Or, for example, you can rotate in this direction. In that case, you will end up with negative. If you calculate this and you put negative and positive and you see these terms, they will be 0, and if you calculate these, for example, instead of I cross J, you can put K, I cross to the K, you can put negative J, and so on, and simplify that. You will be find the answer for this. It is equal to the answer for this determinant. So I, J, K, AX, AY, AZ, BX, BY, BZ. If you expand this determinant, you will find the cross product between A and B. So in order to find faster, instead of writing in this form, we can represent in the determinant form. So in the determinant form, if I write A cross B, I can write I, J, K, AX, AY, AZ, BX, BY, BZ. If we expand this determinant, we know if this will be I times AY, BZ minus AZ, BY minus J. Let's double check to see everything is right. Yes, minus J, AX, BZ minus AZ, BX plus K, AX, BY minus AY, BX. I'm sure you know how to expand this determinant, but I will explain here. The first term I, you will cancel this row and this column. You will put I times, you will cancel this row and column. Then inside of parentheses, AYBZ minus AZBY. Or the second term, you will put negative J, you will cancel this column and first row, so it will be AXBZ minus AZBX. For the last one, you will put K plus K, you will cancel first row and third column, plus K times AXBY minus AYBX. This is the way we will expand 3 by 3 determinant. So, this is about cross product. So, cross product for two parallel vector, if vector A and vector B, they are parallel. Cross product of A cross B will be equal to 0. This we should know. Another things it is important to know the magnitude of the cross product. Because we define A cross B is equal to magnitude of A times magnitude of B times the angle between A and B. For example, if this is vector A, this is vector B, and this angle is theta, you can build one parallelogram using A and B like this. So, the answer for this, A, magnitude of A times B cosine theta, will be area for this parallelogram, and it will be perpendicular to this parallelogram plane. So I can write the magnitude of the resulting, the magnitude of resulting vector which is A times B times sine theta will be equal to the area of parallelogram created by vectors A and B. So the cross product answer for two parallel vectors is always is equal to 0. If they are not parallel, the answer, the magnitude of the vector will be equal to the area of parallelogram built using these two vectors. This is about dot product and cross product. Let's define another term. We call it position vector. If we want to describe the position of one point in a space respect to one origin, we will use the position vector. Assume we have x, y, z coordinate, x, y, z. We have point P. In order to represent the position of P respect to origin O, we will use the position vector, for example, Rp. So if I want to define, I can say a position vector also known as location vector, sometimes they call it. Both of them the same. Sometimes they call it position vector, sometimes location vector. Represents the position of a point, for example point P, in space, here in 3D space, in relation to an arbitrary reference origin. So the position vector, it describes the location of point P respect to origin. For example, here origin O in one space, for example 3D space.